Okay, so in what comes, we're going to kind of round out the picture of what we've been doing in calculus. So we started off in Calc 1 and 2 with scalar functions of a single variable. And then we moved up to vector valued functions of a scalar variable. Then we moved up to scalar functions of multiple variables. And now we're going to complete the picture with vector valued functions of multiple variables. And these are called vector fields. Just a quick note on how mathematicians sometimes write these things. So in this case, we would say f is a function that maps the real numbers to real numbers. Here we could say that r is a function that maps real numbers to points in n-dimensional space. This f is a function that maps n-dimensional points to real values. And then the vector field maps n dimensions to n dimensions. So you might see that kind of notation sometimes in advanced references. Okay, so you've actually seen examples of these beasts before. So for example, if I have a function of 3 variables, a scalar function of 3 variables, so just say x squared minus xy plus e to the z, then we could take its gradient, and the gradient is a vector. So in this case, it's 2x minus y minus x e to the z. And it's a vector that depends on x, y, and z. So this is, in fact, a vector field. Okay, so here where I have 3 variables for each, I actually have 6 things going on, 3 inputs and 3 outputs. So that's really hard to visualize, especially on paper. If we limit ourselves even to just 2 variables, I have 2 inputs and 2 outputs. So it's a 4-dimensional graph somehow, so we still have to kind of fake it a little bit. So for example, let's say that this is our vector field. So we choose a point. Let's choose a point on the x-axis. Okay, so here y is 0, so that means the horizontal part of this is 0, and then the vertical part of this vector is negative. So horizontal 0 and a negative vertical is a vector pointing this way. Now if I go farther out on the x-axis, okay, this doesn't change. This is still 0. This is more negative, so we get a longer vector. All right. Then if we had negative x, it's just the opposite. Still, the first component is still 0, but now the second component is positive and gets larger as you move away from the origin. Okay, and then you can fill that in here. So x is 0, so now there's no vertical, and y is positive, so it goes to the right. If you go up higher, it goes to the right more. Okay, if you're on the negative y-axis, the vertical is still 0, the horizontal is now negative. And so at every point in space, potentially, you can draw an arrow. And you can work out what it should be at different points. Obviously, computers are much better at this than people. But sometimes it's useful to just be able to sketch it so you get an idea. Now, one physical interpretation of a vector field is that it represents, let's say, the flow of water at each point. So at each point, right, the water might be flowing in a particular direction. So this would represent sort of a very swirling kind of flow.